Great. So like I was saying earlier, I'm going to give everyone this handout on Wednesday. And let's look really quickly at these important functions. So the identity function is just the line where every single point is equal. So 1 is on there, 4 is on there, -2, -2, 0, 0. Every single point, x and y are the same. And that's the graph of f of x equals x or y equals x. If we have f of x equals a number, like f of x equals 4 or y equals 4, we go back and forth between y and f of x. So that's important that you see that y and f of x mean the same thing. The times that we need f of x is when we're going to plug something in for x, and we want to see what y gives us that x. But sometimes we're going to write it as y because it's easier to think about it or to visualize it. And for instance, in this case, y equals 4, well, that's a horizontal line where every single y is 4. And no matter what you plug in for x, you get 4. But if we look at it this way, is that showing up? Not really. Let's see. F of x equals 4. That's also not showing up. Let's try this. So now I can track it better. Let's plug in -3. What is f of -3 for this function?
4.
That's right. And what is f of -1,000,000?
4.
Yeah.
But
So no
so-
matter what you plug in for x, f of x is going to be 4. So sometimes the point of the function is easier to see with f of x, and sometimes it's easier with y. So we go back and forth. The square
that-
function is y equals x squared, or f of x equals x squared. And every point on here, the first number squared is the second number. So 2 squared is 4, -2 squared is 4, -1 squared is 1, 0 squared is 0. And it has the parabola shape, like a U. The square root function is like that U shape, but on its side. And every point, the x, if we take the square root of x, we'll get y. So the square root of 0 is 0. The square root of 1 is 1. But the square root of 4 is 2. The square root of 9 is 3. The cubic function is like the square function, except we're going to cube everything instead of square. And here we have something different than the square function. F of 2 is 8 because that's 2 cubed. But this time f of -2, well, what is -2 times -2?
4
Good. Times -2 again.
-8.
Good. So -2 cubed is negative. So this time we get negative and positive answers. Whereas every single answer on the square function is at least 0 or positive. So if we just look at the points, the point 2, 8, or the point -2, -8, 2 cubed is 8, -2 cubed is -8, -1 cubed is -1, 1 cubed is 1, 0 cubed is 0. And the cube root function is like the cubic function on its side. So here we have the points -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Because the cube root of 8 is 2, the cube root of -8 is -2. So exactly the same points, but reversed. So cubic function 2, 8, cube root function 8, 2. Cubic function -2, -8, cube root function -8, -2. Same
You
points,
make-
but just flipped.
Can you make an example for that one? Can you put a number on that one?
Say it again.
Can you make an example for that one?
Oh, sure.
Like,
If we had f of 3, I'm sorry, if we had f of 27, then we would say that the cube root of 27 is what is our answer. Well, what times itself 3 times is 27?
3.
Good. So the point 27 comma 3 would be on this
But,
cube root function.
The square root of 27 is.
This is the cube root.
Oh.
So
Okay.
this is what number times itself 3 times is 27.
Okay.
So we're going backward from the cube. So square function, a square root function, cube root function.
Okay.
And then we have the two that are not really paired with anything. The reciprocal function is just 1 over x. We can have every single y value except 0 and every single x value except 0. And the points are kind of interesting. We have, see if I can see this. We have 1/4, comma 4, and we have 4, comma 1/4. We have 1/3, comma 3, and we have 3, comma 1/3. So every point and its flip is on the same graph. And if you think about it, to undo a cube, you cube root. To undo a square root, you square. But to undo a reciprocal, you reciprocal. You do the same thing. Let's look at that. What if we had y equals 1 over x, and I want to get x. So the goal is to find x. Well, what can I do to both sides so that x is now in the numerator instead of the denominator?
Will you just flip it?
Yeah, both sides. Very good. So we have 1 over y equals x. So the thing that undoes a reciprocal function is itself. And then absolute value is just the distance from that point to the origin. So the absolute value of 3 is 3 because there's 3 units away, and the absolute value of -3 is 3 because -3 is 3 units away from 0. So it's a distance. That's why it's always at least 0 or positive. Absolute value is a distance. So knowing these 8 graphs and being able to visualize them mentally is really important for what we're going to do next. The other sheet that I wanted y'all to have.
I have a question. So on those graphs, would you give us points and then we would have to graph it and then tell you what type of graph it is?
I would say draw the identity function or
Okay.
draw the constant function using the number 3 or draw the square root function.
Okay.
That's a really good question. I'll make sure that everybody knows what I mean when I say that I want you to know those graphs. We're actually going to come back to this page in a minute. But that's the other handout that I had for everybody. Here we go. So we're going to look at transformations, ways that we can change, just in small ways, change these parent functions. If we add a number to the function, then we're going to shift up if the number is positive or down if the number is negative. And the rule is that we're going to add that number to the y coordinate. For instance, here I've got absolute value. So I know that these 3 points, for instance, we've got 1, 1, 0, 0, negative 1, 1. I want to see, how does absolute value minus 3 compare with the regular absolute value? Well, this says I'm going to subtract 3 from y, and I'm going to leave x the same. So we're going to get these 3 new points. I've got, what is 1 minus 3?
-2.
Good, so I've got negative 2, comma 1, 0 minus 3.
-3.
Good, so I've got negative 3, comma 0, and negative 1 minus, no, pardon me, 1 again minus 3, so that'll be negative 1, comma
-2.
negative 2. Thank you. So of course, I'm not doing these correctly. So this is going to be 0, negative 3, the y coordinate, and 1, comma negative 2. And let's check. Do we actually have these 3 new points on our graph? If we shift the whole thing down 3 units. So we're shifting the whole graph down 3 units, and we do actually get these new points. Negative 1, negative 2 is here. Negative 0, negative 3 is at the bottom. And then 1, negative 2 is coming back up. So the rule for going from absolute value x to absolute value of x minus 3 is that we're going to subtract 3 from each y and leave x alone. And the visual is that we're going to move the graph down 3 units. If we have a number subtracted or added to the function inside the function, in other words, if we had f of x equals absolute value of x plus 2, the subtraction or the addition is inside the absolute value instead of outside like here, then that's going to be a horizontal change. It'll be a horizontal side to side. And horizontal changes are always opposite of what they look. If I'm adding, that means I'm going to go to the left. If I'm subtracting, that means I'm going to go to the right. So subtracting h means I'm going h units to the right. Adding h means I'm going h units to the left. And the rule is just add h to each x value. So let's look at it. We've got the square function. So here's f of x equals x squared. And we want to graph x plus 2 squared. So let's take each x in this list and subtract 2 from it. So negative 2, negative 2, 4 becomes negative 4, 4. Negative 1, 1. Let's see, negative 1 minus 2 is negative 3, so negative 3, 1. 0, 0 becomes negative 2, 0. 1, 1, let's see, 1 minus 2 is negative 1, so negative 1, 1, and 2 minus 2 is 0, so this becomes 0, 4. Excuse me. And if we plot these points, we see that they are on the graph. 0, 4, negative 1, 1, negative 2, 0, negative 3, 1, and negative 4, 4.
So since y equals x plus 2, if we say that x plus 2 means take away 2 from x.
Yes, if we're adding inside of the function. So if we're adding inside, we always do the opposite. So adding means subtract, subtracting means add.
Okay.
So if we had h of x equals x minus 4 squared, then we would add 4 to each x to get the new graph.
Mhm. Okay.
And it would be 4 units. The whole graph would be slid 4 units to the right. So it'd be over here.
But if it was a positive, it would be 4 units to the left.
That's right. Yes. So anything that happens inside of the function is going to be reverse of what it looks like. Anything that happens outside of the function is exactly what it looks like. Okay, I think that I have the sheet with it. I found it filled in. Here we go. So let's take the square root function, and graph g of x, which is the square root of x minus 3, all plus 2. And to do that, we're going to trace 2 points. So we're going to do the horizontal translation first, and then the vertical. So with a horizontal translation, if I'm subtracting 3 inside the function, what am I doing and which variable?
So you're going to add 3 to 0.
To which variable, x or y?
X.
Y.
So horizontal means x, and that 3 is not a clear 3. So let's see, 0, 0 is going to become
3, 0.
good. So we get 3, 0. And what about 4, 2? What is that going to become?
Is it 1, 2?
So we're adding 3 to each x.
So 7.
Very good. And now we're going to take these 2 points, 3, 0 and 7, 2. And we're going to apply the second change, which is where the whole graph is going to be added. So that's vertical. If I'm adding 2, I can add what to which variable?
Would it be the y?
It'll be to y. Very good. And what are we going to add to y?
Is it 2?
Very good. So let's see. The point 3, 0 will become
3,
3,
2.
2.
very good. And the point 7, 2 will become
7, 2.
we're
I mean,
7,
7.
4.
7, 4. Good. So let's graph these 6 points. And let's see. I'm going to try to find. Here we go. I knew I had some somewhere. So the first one, let's pull a black out. I'm going to plot the points 0, 0 and 4, 2, just to remember what my normal square root function looks like. And now let's get, this is as close as I've got to purple. So let's plot 3, 0 and 7, 2. So the first is a horizontal slide, 3 units. We got that by adding 3 to each x. Let's put that graph on the next coordinate plane. 7, 2. So this is y equals the square root of x minus 3. Y equals the square root of x minus 3. And then let's apply the last translation. So we're going to plot the points 3, 2 and 7, 4. So there's the graph of the final function. G of x is the square root of x minus 3 plus 2. Do you sort of see why it's important to know these parent functions? That's
little bit.
Pardon?
A little bit.
Because we're going to be manipulating them. So we really need to have a good picture of those basic functions. Okay, the next important kinds of transformations are reflections. If we have a negative outside the function, then we're reflecting with respect to the x-axis, and the rule is that y changes its sign. So let's look at this example, and then let's look at the horizontal reflection. Here we have g of x is negative x squared. And we're going to compare that with f of x equals positive x squared. So with positive x squared, we have these points 0, 0, and 2, 4. And all I'm going to do, it says change the sign of y. Here y is 0, so it's going to stay 0. But here y is 4, it's going to become negative 4. So those 2 points, here's 0, 0. Here's 2, 4. Zero, 0 is staying, but this 2, 4 becomes 2, negative 4. And the effect is that every single point will be reflected with respect to the x-axis. So all we're doing is flipping, but we're flipping vertically. If we have a negative inside the function, then we're reflecting with respect to the y-axis, and the rule is to change the sign of x. Well, here's an example of that. We've got f of x is the square root of x, and g of x is negative. The square root of negative x. So I'm going to look at the 2 points we looked at for when we were looking at the square root function before. We have 0, 0, and 4, 2. So here's 0, 0, and 4, 2. And the rule says, change the sign of x. 0, 0, negative 0, still 0. But 4, 2, I'm going to change the sign of x. That'll become negative 4, 2. And the effect is that every single point reflects with respect to the y-axis. But do you see that the changes on the horizontal, here the change is vertical. Here the negative is on the outside and it's vertical. Here the negative is on the inside and it's horizontal. It's always going to be like that. Oh, we did this. Okay, great. So this is actually kind of fun. We're looking at a graph that is given. So we're pretending we don't have the others on there yet. And they've just given us something strange. Y equals f of x is just these 3 line segments. And we want to graph negative f of x and f of negative x. For f of negative x, for negative f of x, we're going to change the sign of which one, y or x?
Why?
Y, that's right. So for momento, por favor. So when we just change the sign of y, we are changing everything vertically. And when we change the sign of x, we're changing everything horizontally. So 0, -1 becomes, because here's that point, here's 0, -1. And it says, change the sign of y. Well, that becomes 0, +1. The point 0, 0 right here, it doesn't move because if I negate 0, I still get 0.
0.00. That's not the
Pardon?
0.00.
Say again?
Oh, that's not the 0.00.
Oh, thank you. This is the point 1, 0. But still, yes, so the y is still 0. Thank you
Oh,
very
yeah,
much,
yeah.
Aldo.
Okay.
So up here we have the point 3, 2. If I change the sign of y, but leave x the same, what do I get?
3, -2.
Very good. So here I've got the point 4, 2. Where does that go?
4, -2.
Excellent. And finally, we have the point 5, 0. And where does that go?
It stays there.
And that's because if we change the sign of 0, it's still 0. Do you see that we're changing the whole graph vertically?
Mhm.
If we change the signs of all of the x coordinates, the change is going to be horizontal. So let's just plot again. We had 0, -1, 3, 2, 1, 0, 4, 2, and 5, 0.
I have a question.
Yeah.
So would a question that you would give us be, you would give us the original plots and then you would tell us to graph a vertical reflection and then that's where we would go? Is that how it would?
Yeah, or I would say graph, if this is f of x, graph negative f of x,
Okay.
or graph f of negative x. So yes, those are either of those questions would be correct.
That you would give us the original, like the 0, -1, 1, 0, 2, 1.
Yes.
Okay.
And I would either give you f of negative x as the goal or negative f of x as the goal.
Okay.
And then you would need to remember, okay, if the negative is on the outside, I'm changing the sign of y. If the negative is on the inside, I'm changing the sign of x. And let's see how that works. We've got 0, -1. If I change the sign of x, where is that point going?
It's gonna stay there.
That's right, because x is still 0. So we still have 0, -1. What about the point 1, 0? If I change the sign of x, is that point moving?
Would be
Yes.
-1, 0.
Good. And then up at 3, 2, change the sign of x and we get
-3, 2.
4, 2 becomes,
-4, 2.
and then 5, 0.
-5, 0.
And that has the effect of moving things horizontally. there's one more kind of transformation, and that's a stretch or a shrink. If a number is multiplied on the outside of the function and that number is greater than 1, then the function will be stretched vertically and will multiply every y by a. Multiply every y by a. If the number that we're multiplying by is between 0 and 1, we'll divide by a, or we'll multiply by 1 over a, all of the y's. We're always going to think of a as positive, though, because if the number is negative, we're going to do this horizontal or vertical flip first. So the number's always going to be positive. It's either going to be greater than 1 or between 0 and 1. What if the number is 1? Why did I leave that out?
Because
did I
that's
not
what you're
include-
starting with.
Yes, exactly. Very good. Very good. So let's look at an example of that. If I've got my original function as the absolute value of x, and I want to graph 2 times the absolute value of x. So I'm going to take, I've got 5 points here, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And now I have a black, here we go. I've got -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. The rule said take every y and multiply it by 2. So let's do that rule to these points. What am I going to get if I start with -2, 2, and I multiply the y value by 2?
-2, 4.
Good. Let's see where that is. -2, 4, -2, 4 is up here. What if I have -1, 1, and I'm multiplying y by 2?
-1, 2.
Good. -1, 2. 0, 0, is that going to change?
No.
1, 1 becomes
1, 2.
good. And 2, 2 becomes
2, 4.
good. And do you see that the graph is kind of stretched vertically? The other that we want to graph is 1/2 times absolute value of x. So we can think of this as multiplying every y by 1/2 or dividing y by 2. Either way is correct. So now I started with -2, 2. What am I going to get if I divide every y by 2?
1.
Good. So here's the point. -2, 1. What about 0, 0? What are we going to get?
0, 0.
Good. And 2, 2, we divide y by 2 and we get
2, 1.
good. And do you see that we kind of squished it vertically? We smushed it down. The absolute value.
That's stretching.
So yeah, we've got our normal absolute value.
Okay.
The red curve is stretched. The blue curve is shrunk or smushed.
So on the 2, 2, on the blue part, should it be 2, 1?
should be 2, 1. Y'all are all gonna have so many extra points. Thank you. So the other kind of stretching or shrinking is if the number is multiplied by x on the inside of the function. Again, we're only considering positive numbers. If the number is negative, we're going to do the negative part separately. That'll be a flip. So we're only thinking of a being positive. So it's either going to be greater than 1 or between 0 and 1. If it's greater than 1, we're going to divide by a. And if it's between 0 and 1, we're going to multiply by a. And that's because it's inside the function, and we always do the opposite. So let's look at an example of that. We've got y equals x squared. What color? Oh, the green, it's green. Here we go. And the points I want to look at are negative 2, 4. This is y equals x squared. Negative 1, 1, 0, 0, 1, 1, and 2, 4. We said that the rule, if we have a number inside the function, if the number's bigger than 1, we're going to divide by it. So for instance, f of 2x. What am I going to do with the x if I have, here we go, if I have f of 2x?
Divide by 2.
Yes, and negative 2 divided by 2 is negative 1. So the point, let's see, the point negative 2, 4 becomes negative 1, 4. Zero, 0 is going to stay. What about 2, 4? What is that going to become?
1, 4.
1, 4. So let's see. Here's 2, 4. And here's 1, 4. The 0, 0 stays the same. And I didn't bother dealing with the numbers, the points that didn't have a factor of 2 for the x. I wanted it to be easy to divide. I can see what the graph is going to look like just by looking at 3 points. Well, now let's see what happens if we divide x by 2 or multiply x by 1/2. So the point negative 2, 4 becomes, because what are we doing to the x here? If the number is between 0 and 1, we're going to
Divide. Multiply.
multiply by it. That's right.
Multiply by-
So here we're going to multiply by a, and a is 2 this time. So here a is 2, here a is 1/2, or we're dividing, here we're multiplying. So negative 2, 4 becomes
Negative 4. 4.
good. So let's see, negative 4, 4 is way out here. The point 0, 0 stays. And the point 2, 4 becomes
4, 4.
4, 4. Let's see. Do you see that the graph that is f of 1/2 x is just stretched horizontally. And the graph that is f of 2x is pushed in horizontally.
Uh-huh.
Good. Part of what I'm going to give y'all on Wednesday is the sheet that I'm going to give you as soon as I find it. Here it is. So all of the rules, you can always have all the rules. So if you're adding or subtracting from the whole function, you're going to add or subtract from y. If you're subtracting or adding inside the function, you're going to add or subtract the x. If you negate the outside, you're going to change the sign of y. If you negate the inside, you're going to change the sign of x. If you multiply on the outside by a number bigger than 1, you're going to multiply y by that number. If you multiply on the outside of a function by a number between 0 and 1, you're going to divide by that number. And if you're inside and you've got f of a number times x, then the rule is if a is bigger than 1, we're going to divide by it. If it's between 0 and 1, we're going to multiply by it. Hi, what's your name?
Hi.
Say hi.
Hi.
Do you want to do some algebra? You will very soon. Your mom won't believe it.
I'm in first grade.
Wow, that's wonderful.
So I have a question. So with these notes, is this something that we need to put on our little cheat sheet for the test, or are we allowed to have this on top of that?
You'll be able to have this on top of that.
Okay.
What I'm hoping is that you won't need this, but actually you can have this as well. But I want you to have these pictures in your mind in addition to having them here, so that when you're moving them around, you can visualize it more easily. But you'll have both of these, this sheet and this one,
Okay.
in addition to your other page of notes. It's important that the transformations have their own order of operations. You do a horizontal translation first, and then any horizontal stretch or shrink next, a vertical stretch or shrink after that, an x-axis reflection, y-axis reflection, and finally a vertical translation. So this order of operations is really important. And you'll have that on the sheet as well. So we're going to keep that to the side. I'm going to try to do this next example without using the pictures that I already have. So the graph that we're going to find is f of x is -1/2 times x minus 2 squared plus 3. So let's write that down here. F of x is -1/2 x minus 2 squared plus 3. And we're going to do horizontal translation first. Horizontal. This time, do we have any horizontal stretch or shrink?
Can you remember the rule?
Do we have a number multiplied by x inside the parentheses?
No.
That's right. So do we have a vertical stretch or shrink?
Yes, because it has a number greater than 1
That's right.
Right.
Well, it has a number less than 1, but yes.
or less than 1. Yes.
Yeah. So we have a vertical shrink. Then do we have any reflections?
I don't think so.
This
Because it'd be
negative,
the opposite, right?
yeah, so the negative on the outside means we have a vertical reflection. I always do this, reflection. And then the +3 on the very outside says that the last thing we're going to do is a vertical translation. I can't spell today at all. That word
So-
is translation.
So are you basically taking the equation and looking at all of the different transformations to see where it fits?
Yes, but I'm going to do them one at a time.
Okay.
So I'm going to start. What is the parent function? What is our main function here?
Parabola. Parabola.
Yeah, so it's x squared, the square function. So let's plot, let's think of 3 points that are easy to graph on the square function.
1, 1, minus 1, 1.
Okay, -1, 1, 1,
0,
1,
0.
and then we have and 0, 0. Good. Those are wonderful 3 points to use. Now, what does a horizontal translation do? Does it change x or y?
X.
Changes x, that's right. Everything horizontal changes x, everything vertical changes y. So with a horizontal anything, it's always backward. If I'm subtracting 2, what am I going to do to x? Add 2. What is my point -1, 1 going to become?
1, 1,
Good.
1.
Good. 0, 0 becomes,
2, 0.
yeah, 0 plus 2 is going to become,
2, 0.
and then the
Yeah.
point 1, 1 will become,
3, 1.
excellent. Now this vertical shrink, I'm going to divide y, because it's vertical, by 2. What is 1, 1 going to become?
1 and 1 and 0.5.
Well, we're going to write it as 1/2, but yes. And then 2, 0 becomes,
2, 0.
good. 3, 1 becomes,
3, 1/2.
very good. All right. A vertical reflection, that's because this negative sign out here. What does that do? What change happens with a vertical reflection?
Is the opposite.
Which thing changes? Which letter, X or Y?
Y.
Why?
That's right. Y is going to change sign. So Y changes sign. So what is the point 1, 1/2 going to become?
1,
negative. Yeah.
-1/2.
Good. And 2, 0,
2, 0.
good. And 3, 1/2,
3, -1/2.
excellent. And then finally, we're looking at the vertical translation. If we're adding 3 to the whole function, what do we do? And which variable does it change?
Y changes.
Why?
Yeah, and what are we doing to Y?
Adding 3.
Adding 3. And just because I think it's fun, I'm going to remember that 3/1 is the same as, let's see, I multiply by 2/2, I get 6/2, and that'll make it easier to deal with these 1/2s. So if I'm adding 3, that's the same as adding 6/2. And am I changing X or Y?
Y.
That's right. -1/2 plus 6/2 will be
5/2.
good. So we get 1 5/2. 0 plus 3. We can do that easily. What is 0 plus 3?
0, 3. Oh, well, 2, 3.
Very good. And then again, -1/2 plus 6/2.
Is 3, 5/2.
Good. Very good. So what we're going to do, and I'm going to go ahead and use my pretty graphs because it's easier, but we're going to take these 3 points and trace them. So here's the first graph. Here's just y equals x squared in black. And I've got the points -1, 1, 0, 0, 1, 1. Let's see, it was purple first. And the closest I have to purple is this color. What did -1, 1 become?
1, 1.
1, 1. Let's see. So, and 0, 0 became
Same. I know, 2, 0.
good. And 1, 1 became
3, 1.
3, 1.
Horizontal.
So
And
even-
because it's a positive, that's why it's moving to the right.
That's right. That's right. Because we're subtracting inside, we're going to add. It's always backward if it's inside. So these first, even though we're only looking at 3 points, we can see the shape of the whole thing because we know what x squared looks like. Now we're going to take these same 3 points. So let's put them on the here again. We have 2, 0, 3, 1, and 1, 1. And we multiplied every y by 1/2, or we divided all the y's by 2. So we get the point 1, 1/2, and that's in green. So 1, 1/2. The point 2, 0 stays, and the point 3, 1 becomes 3, 1/2. So those 3 points show what's happening to the whole graph. Do you see that you don't have to trace every point to see what's happening with the graph? All right, let's look at those 3 points that we just graphed. We had 1, 1/2, 2, 0, and 3, 1/2. And the next thing was this vertical reflection. For the vertical reflection, we changed all of the y's. So 1, 1/2 became 1, -1/2. Let's see. 1 +1/2 becomes 1 -1/2. 2, 0 stays. And 3 +1/2 becomes 3 -1/2. We have those same 3 points again. 1, 1/2, 2, 0, and 3, 1/2. And finally, we're adding 6/2 or 3 to each y. It's red. Here we go. So we have the point 1, 5/2, the point 2, 3, and the point 3, 5/2. So do you see that tracing 3 points if I know what x squared looks like, if I know the main function, tracing 3 points is enough to see what's going on. So the final graph, we could have gone straight from these points, -1, 1, 0, 0, 1, 1, all the way to the end. But I think it's good practice to see the stages. In the notes, I added another point, 2, 4, just so that you could see one more point being changed. But what's important is tracing 3. If you can always trace 3 points, that's enough to see the shape. And for the square root, 2 points is enough because there's no symmetry with square root. Any questions before we try to do something on our own? Which? Oh, this one first. Okay. So I want y'all, and I'll help some. So we're going to graph h of x equals negative square root of x plus 2 all minus 3. So the main graph is what? What is the parent function?
Square root.
Good. And I said 2 points are enough for square root. So let's see. I'm going to start with 0, 0, 1, 1, and maybe we'll have room for 4, 2. The reason that 2 points are enough with square root is that square root only has one part. It only has one arm. We don't have any flip or symmetry. Okay, what is the first thing I'm going to do in order to graph this function? I've got my rules. It says that the first thing we always do is a horizontal translation, if there is one. Is there a horizontal translation?
Yes.
Okay, and what are we going to change? Which variable, x or y?
X.
Okay, we're going to use x, and we're going to add or subtract what number?
Subtract 2.
Subtract 2. Okay, good. So 0, 0 becomes
Minus 2. 0.
good. 1, 1 becomes
Minus 1, 0.
and 4, 2 becomes
2, 2.
good. The next thing is if we have any vertical or horizontal shrinks or stretches, but we don't this time. So we're going to do any reflections next. Do we have a reflection here? Do we have a negative on the outside or inside of the function?
Yes.
Okay, and is it on the outside or the inside?
Outside.
So we're going to change y, and every y will become the opposite. If it's negative, it will become positive. If it's positive, it will become negative. What will the point -2, 0 become?
Negative 2, 0.
What about -1, 1?
Negative 1, negative 1.
Good. And 2, 2.
2, negative 2.
Excellent. The last thing that we have is this -3 on the outside. Does that change y or x?
Y.
That's right. And do we add or subtract that number?
Subtract.
That's right. So if I have the point -2, 0, and I'm only changing the y, and I'm subtracting 3 from each y, what does negative 2, 0 become?
-2, -3.
Excellent. What about -1, -1?
-1, -4.
Excellent. And 2, -2.
2, -5.
Excellent. So let's see if it really is good enough, if I don't have a graph already nice in front of me, for us just to plot these 3 points as we trace. So our original graph is 0, 0, 1, 1, and 4, 2. And that's y equals x squared. I mean, y equals the square root of x. Now we want to graph -2, 0, -1, 1, and 2, 2. Let's see. So now it's kind of easier to see that what I just did was a horizontal translation, a horizontal slide. So this graph, the red one, is y equals the square root of x plus 2. Now let's do the vertical translation, vertical reflection. So the point -2, 0 stays. The point -1, 1 becomes -1, -1. And the point 2, 2 becomes 2, -2. So let's see, here's 2, 2. 2, -2. And because I know the basic shape, 3 points are enough. And then finally, we're going to shift everything down 3 units. So the point -2, 0 becomes -2, -3. The point -1, -1 becomes -1, -4. And the point 2, -2 becomes 2, -5. And that's the final. And let me show you a prettier version of it.
So on the green one, that's the vertical reflection, correct?
Yes, that's right.
So that would be y equals,
Y is changing sign.
okay.
Every positive becomes negative, every negative becomes positive. So here's what it looks like in the notes, or in my notes. So when we shifted back 2, when we reflected, and then when we shift down 3. And we traced the same 3 points. Okay, I want y'all to, let's see if this works. I want y'all to graph g of x equals 2 times the absolute value of x plus 1 all minus 3. And I want you to use these points. Here's y equals the absolute value of x. Let's start with -1, 1, 0, 0, and 1, 1. And I'm gonna write it down, but I want y'all to do the talking. I'm gonna go away. I'm just gonna be here to write.
Okay. See the horizontal translation? Yes, there is.
So in the first one, we're gonna change x, right? For
Yes.
minus
think-
2.
No, -1.
Oh, -1.
So, it's, all right. So we're gonna do 0, 0,1. First point is gonna be 0,1.
Would it be -2, 1?
Oh, yeah, yeah, two, correct.
And the second one be -1, 0. The third one would be 0, 1. And then 1, 2.
No, that's only 3 points.
Oh, sorry, I was going on.
So next one is any vehicle. Vehicle shrink. See, yeah, there is vehicle shrink. So we're gonna change y. Divide by 2. Multiply by 2. Okay. That's gonna be, first point is -1, 2. Oh, no. Minus 2, -2, 2. -1, 0. 0, 2. Good. 1. Okay, next one it is any reflections? Looks like no.
So would we do the reflection and change the sign?
Is it y plus 3?
There's no reflection on this one.
Okay.
So, yeah. Medical translation. It's going to be change the y. Well, subtract 3 from y. So -2, comma -1. -1, comma -3.
And then 0, comma, -1.
And here's, let's go ahead and try to graph these points. on a test or a quiz or anything like that, not only will I have axes for you to draw on, but the format that I use is that I'll have blank units, blank, add blank to blank. So you have to figure out, are you changing X or are you changing Y? And how are you changing X or Y? So it's going to be like this. You'll have these numbers, however many I want you to follow. And then using the order of operations for transformations, we'll have, it'll be horizontal, vertical, vertical, vertical. And then you'll trace those points along. There, let me show you. I'm going to change my share. Can you see my
Yes.
page? Okay, so let me go up here. So here's the way I would give it to you. We have the first two graphs. I won't necessarily give you those, but I will give you the points I want you to trace, and it'll say shift horizontally, blank units blank. And I want you to write the rule. And shift vertically, blank units blank. So for this one, it would be, the horizontal one would be 1 unit left. And the vertical shift would be 3 units down. And the rule for the Y would be subtract 3 from Y. The rule for the horizontal translation is subtract 1 from X. And the reflection here shouldn't be reflection, it should be a stretch. But the rule is just multiply Y by 2 for this middle column.
Can you say what the first one, the horizontal shift?
Yeah, I'm going to go back to the, let me go back to the overhead, because you can see what it actually is. So here are the, we have horizontal, 3 units right, and the rule is add 3 to X.
So for the one that we just did,
Oh, I'm sorry. Thank you. For the one that we just did is this one. So we shift horizontally 1 unit. So it's subtract 1 from X. Then multiply Y by 2, then subtract 3 from Y. If I want you to follow 3 points, I'll put 3 points. If I want you to do more, I'll put more. And once you've got this filled in, it's very easy to trace the points, to trace the graph. So let's see. I know I have a black pen. Here we go. So let's start with the parent function. -1, 1, 0, 0, and 1, 1. This is Y equals the absolute value of X. The next change, what color did I do? Looks like purple. The closest I have to purple is this color. So -1, 1 becomes -2, 1. Let's see, -2, 1. 0, 0 becomes -1, 0. And 0 and 1, 1 becomes 0, 1. So this purple graph is Y equals the absolute value of X plus 1. Then we stretched the y by 2, and it looks like I did that in green. So the point -2, 1 becomes -2, 2. The point -1, 0 becomes -1, 0. And the point 0, 1 becomes 0, 2. So this green is the graph of y equals 2 times x plus 1 in absolute value. And then finally, we're going to shift the whole thing down 3. And we have -2, -1, -1, -3, and 0, -1. So the blue graph is the final, the black is the original, and the blue graph is 2 times the absolute value of x plus 1, all minus 3. Oh, we've gone over time. And Alicia, you had to leave at 7. It's past 7.
It's okay. It's okay.
Well, this is how far I wanted to go. So what I'm going to do is go ahead and upload the graphs that are nice and pretty, in addition to these notes, so that you've got the pretty version as well.
I have a question on the last one that you drew, the blue line.
Yes,
What was that? What was it? Did you write y equals
it's y
Oh, it's right
equals
there.
or g of x equals, yes.
g of x equals
And I
2?
wrote g of x up for it because it's the only one that we named.
Okay. Okay. Thank you.
And you can see it better here. When I do them on the computer, it really messes up everything if I do more than 2 on one graph. So I just do 2 at a time. But for when you're doing it yourself, you can kind of follow it. I've tried to do it all on one graph, and it's a mess. It's not easy to follow. So
When we're doing it, will we be doing it all on one graph?
you can choose. You'll have more than one axis to use on the page. So you'll have several blanks,
Okay.
and you'll have the table, and you can choose how you want to trace it out. Some students only want to draw the very first and the very last, and that's fine. But if the very last is not correct, then that doesn't help me out for grading. So the more stuff you show in the middle, the better. Any questions at all? Oh, if you're watching this, please text me the word hello. So if you're watching this video later, please text the word hello to me, and I'll know that you've seen the video. Yay.
That's for us too.
No, you don't have to do that.
Okay.
So the 4 students who are here do not have to do that.
What do you mention about uploading?
Oh, so I'm gonna send these notes as well. The notes that I use with the solutions, I usually only post them to our page. Let me show y'all really fast. So let's go to Canvas page. Under modules and under notes. So I always post the notes with solutions on our page, but I don't send them out. because some students wouldn't take notes if I did send them out. But this time I think I'm going to go ahead and send out the pretty version and the blank notes so that you've got something nice to in your notes. And this little handout here, this third item, that's what everybody is getting, but I'm also going to send it out. I tried to send it out before. And that's just a handout with those 2 pages. I really don't want you to try to memorize these things, but just be able to memorize the functions. But the order of operations and all of the transformations, I just want you to be able to follow it. Okay, let me get rid of that. Vienna, just let me know that you're here.
I'm here.
Okay, swell, thanks. Okay, well, if there are no questions, this is great. We actually went a little bit over, I think. We started a little bit late though.
How do we prepare for Wednesday?
How can you prepare for Wednesday? You are gonna do great. You who are here are gonna do great. So what I want you to do for Wednesday is try to learn the name and the shape of each of those 8 graphs. Identity function, constant function, square, square root, cubic, cube root, absolute value, and then like this for the inverse function. Because the better you can visualize those, the better you can move them around. Have a lovely week, and thank you very much for coming this evening.
Thank you.
All right, thank
Thank
you. We'll see
you.
you
You have a
Wednesday.
great day.
Okay,
Mm.
bye.
Bye.